Are you curious? Just genuinely. Then you must want to find out about halogens.
First of all, forget everything you know about Halo, because they are not related.
Are you sure about that?
Yeah, we're sure.
We're sure. Welcome to the Hyper Halo Show, episode 17.
Just on a general introduction on who we are, we were very professional military commandos in a scientific military base.
But unfortunately, we got struck hard by a lightning bolt on our heads, and we suddenly realized that the purpose in our life was nothing. But it suddenly hit us that we did have a purpose, and it was science.
Because science is life. Today's topic in the Hyper Halos, we are talking about halogens. Specifically, what they do, their origins, defining the family, and everything relating to halogens and the elements, and how they affect us. And how about we start with a fun fact? The name halogen is probably familiar to most people because of the term halogen lamp, used for automobile headlights, spotlights, and floodlights. And the halogen lamp is much more effective than ordinary incandescent light.
Then that means I see halogen lamps every day in my life when I come to school and go home.
Yeah!
Well, another fact of information, there are 6 elements in the halogens group.
Fluorine, chlorine, bromine, iodine, acetylene, tennessine. Due to the interruption of kids, I think we have to move ground.
Oh no! In this group of elements, as we go down, the element's electronegative reactivity gets lower. If you're dumb like Zane, then that means that the reactive energy gets less. The reason why fluorine is so highly reactive is because the electrons on the outer shell, all the valence electrons, are much closer to the nucleus. And because of this, they get attracted towards the nucleus and they stay close tightly. And since there are only 7, they need 1 more electron with 8 electrons in order to become stable, and with this covalent bond they are able to attract 1 electron from the other element in order to become happy and become stable.
Every element in the group has 7 valence electrons. And just for a reminder, a valence electron is an electron that is associated with an atom and can participate in the formation of a chemical bond.
Do you remember what is ion? Let's talk to another professional.
An ion is an atom or molecule with a net electric charge due to the loss or gain of 1 or more electrons.
The ions that are formed in the elements of halogens have a single negative charge.
When a positive ion gets attracted to a negative ion or vice versa, it's bonding with the other, and as a result, 2 oppositely charged ions are generated.
Nice.
Since halogens have 7 valence electrons, and because they need 8 to become stable, they constantly try to borrow 1 electron from the other elements in order to become stable and complete the bonding process.
The halogen group starts off with fluorine, and this element is the most highly reactive element. Highly reactive within its group.
Highly reactive within its group.
And it is a pale yellow-green and dangerously reactive gas which reacts very highly with hydrogen. Its atomic number is 9, which means it has 9 protons and also 9 electrons, because an atom needs the same amount of electrons and protons in order to be stable. And if you want to know the neutrons, then you just add these up and subtract them from the average atomic mass, which means there are 10 neutrons.
Another important fact is that it was founded in 1886 by a French chemist named Henri Moissan. It occurs naturally in the Earth's crust as rocks, coal, and clay. These fluorides are released into the air in wind-blown soil.
Secondly, we have...
Hey, stop talking.
No, what?
People are bored of you, let me talk. I'm the handsome one.
Fine, go on.
Secondly, we have chlorine, which is a greenish, yellow, diatomic, dense gas with a sharp smell. It's like the smell of bleach. Oh god! It is found free in nature as it combines readily with nearly all the other elements. Chlorine occurs in nature mainly as common salt, caronite, and sylvite. in its liquid and solid form, it is powerful for bleaching.
Actually, Zane, you know what?
What?
Chlorine isn't the only thing that can clean swimming pools.
Oh, really?
Or is used in it. Bromine is also another alternative because brominated retardants, or which means like retardants that are, or things or chemicals that are less flammable, are also used in televisions, computers, domestic appliances such as phones, mobile phones, furniture, upholstery, and mattresses. And bromine is found most significantly in the brine deposits, which means saturated salt deposits, and that is mainly in Israel's Dead Sea, as well as in the Arkansas and Michigan.
The credit for the isolation of bromine is usually given to the French chemist Antoine Jerome Blard, a great man. Though, in fact, German chemist Karl Loewig, another great man, actually isolated first in 1825.
Zane, did you know where the name iodine, or where the word iodine was derived from?
I knew you were a stalker.
You call this stalking? Well, it originated from the Greek word that is translated as violet colored. And a reference to this is that when it reacts with something, it creates dark purple crystals.
Thank you very much, Praveen. But now, let the professional talk.
Professional.
Iodine was first isolated in 1811 from ashes of seaweed by the French chemist Bernard Crutoy, and during the 1800s, iodine was obtained commercially from mines in Chile. But during the 20th century, wells of saturated salt brine in Japan, Oklahoma, and Michigan have proven to be a better source. We always consume iodine in our daily lives, and because it is an important form of human diet, and it has proteins such as fish and and vegetables and stuff.
Yummy, yummy. Well, that was professional after all, eh?
Told you.
Well, moving on to our last and very rarest element of all the elements. Oh, looks like the birds also want to listen to us, eh? Well, moving on to our last element, acetine. In any given time, the substance is located or would be present in about at least 25 grams within the Earth's crust. It's produced synthetically by bombarding bismuth, which is a chemical element of atomic number 83 and is a brittle reddish gray metal, along with alpha particles.
And that's about it.
Thank you very much, my friends.
And be sure to come on this show next week for episode 18.
Basically, life is empty without halogen.